Welcome to Wonderscape, where we peel back the surface of the world to reveal the systems quietly holding it together. Imagine driving down a road and suddenly realizing the lake is on top of you. Not flooding, not leaking. Intentionally placed there. This is not about aqueducts only. This is about one stubborn rule engineers refuse to break. Boats do not stop. When water traffic met land traffic, engineers made a choice. They did not slow ships down. They did not reroute canals. They forced roads to surrender. From submerged highways to floating rivers and machines that lift entire canals into the sky, these are 10 times engineers refused to make boats stop. And by the end, you will realize something unsettling. In the hierarchy of human movement, roads come second. Land obeys, water commands. This isn't a list of cool bridges. It's a manifesto showing how engineers quietly chose water over land, again and again. 1. Veluwemeer Aqueduct, Netherlands, 2002. Let's start with the moment that breaks your brain instantly. At Veluwemeer, cars drive under a lake. Completed in 2002, it's one of the clearest examples of modern hydraulic priority. No gates, no drawbridge, no waiting. Boats glide calmly overhead while traffic flows beneath the waterline. It feels illegal. It feels wrong. But this is precision engineering at its cleanest. Instead of lifting a bridge every few minutes and stopping traffic, engineers lowered the road, sealed it, reinforced it, and let water pass freely above. Hydraulic command. Mechanical obedience. Boats never slow down. Cars accept the burden. This is the rule, revealed. And once you see it, you can't unsee it. Because this was not a one-time experiment. 2. Ringvaart Aqueduct, Netherlands, 1961. If Veluwemeer feels like a trick, Ringvaart proves it is policy. Same philosophy, different scale. Built in 1961, Ringvaart shows this wasn't a modern trend. It was already doctrine. Here again, water crosses above vehicles without interruption. Not because it is flashy, but because it is efficient. This aqueduct exists for one reason. Stopping boats costs more than rebuilding roads. The Dutch understood something early. Waterways are arteries. Interrupt them, and the entire system suffers. So roads bend, roads dip, roads disappear, land yields, water advances. And now that the pattern is clear, history steps in. 3. Avon Aqueduct, Scotland, 1821. Long before modern concrete and steel, engineers were already making the same decision. The Avon Aqueduct does not sit low and discreet. It rises. Stone arches carry a canal high above the landscape, forcing everything below to submit. Completed in 1821, it proved that even early engineers chose elevation over interruption. This was not convenience. This was ambition. In an era without modern machinery, they still chose not to stop boats. They lifted the water instead. This is where hydraulic priority becomes architectural doctrine. And this raises the stakes, because once water starts climbing into the sky, there is no turning back. 4. Pontcysyllte Aqueduct, Wales, 1805. This is where engineering becomes emotional. Pontcysyllte is not just high, it is terrifyingly high. A narrow ribbon of water floats above a deep valley supported by slender iron and stone. Finished in 1805, it has been defying gravity and fear for over 2 centuries. There are no guardrails for the canal. Boats appear to drift through the air. This is not over-engineering. This is confidence. Mechanical fear. Hydraulic certainty. Stopping boats was never an option. But now the scale begins to overwhelm the senses. And that brings us to weight. 5. Briare Aqueduct, France, 1896. If Pontcysyllte feels delicate, Briare feels unstoppable. This aqueduct carries a full canal over a river. Not a trickle. A massive body of moving water. The weight alone is staggering. thousands of tons suspended above another waterway. Completed in 1896, it was one of the first large-scale steel aqueducts in Europe. Engineers here were not experimenting. They were declaring authority. Water traffic ruled commerce. Roads existed to accommodate it. And right when the viewer thinks they understand the formula, the video turns. Up to now, roads surrendered quietly. But what if engineers refused to drown roads at all? What if instead, they moved them? If this is blowing your mind already, pause for 1 second. Like the video, subscribe to Wonderscape, because what comes next flips the entire idea upside down. 6. Barton Road Swing Bridge, England, 1893. At Barton Road, water does not rise. The road leaves. Built in 1893, it's one of the earliest mechanical negotiations between land and water. Instead of submerging traffic or lifting canals, engineers made the entire roadway swing away like a door. Ships pass uninterrupted. Cars wait. Mechanical surrender in its purest form. A road stepping aside for a boat. It feels polite, temporary, almost humble. But it sets the stage for something far more chaotic. Because sometimes, everything overlaps. 7. Håverud Aqueduct, Sweden, 1868. This should not exist. At Håverud, water crosses above roads, while trains pass beside it, all stacked into one impossible knot. Completed in 1868, it solved a terrain problem engineers once considered impossible. This is layered engineering, a vertical negotiation between systems that refuse to yield. Nothing stops. Everything adapts. Miss one calculation here, and the entire structure collapses. This is the closest land ever gets to equality, and even here, water still holds the upper tier. And now, after centuries of trial and error, modern engineering steps in to show what dominance really looks like. 8. Magdeburg Water Bridge, Germany, 2003. This is the largest navigable aqueduct on Earth. Opened in 2003, it connected two major waterways that had been separated for decades. A full canal crosses another canal. In midair, ships sail across a bridge filled with water, suspended by modern steel and concrete. No locks, no waiting, no compromises. This is not about necessity anymore. This is engineering flex, hydraulic supremacy made visible. But even this is not the peak, because someone asked a dangerous question. How far would we go just so boats don't stop? 9. Falkirk Wheel, Scotland, 2002. The answer was all the way. The Falkirk Wheel does not reroute water. It lifts it. Entire canals are rotated through the air, raising boats between elevations like a mechanical ritual. Completed in 2002, it replaced a system of 11 locks with a single rotating lift. This is no longer infrastructure. This is choreography. Energy efficient, precise, almost theatrical. And yet, it still exists for the same stubborn reason. Boats must keep moving, but the final example changes everything. 10. Krabbersgat Naviduct, Netherlands, 2003. This is the final form. Opened in 2003, it remains the only naviduct of its kind in the world. At Krabbersgat, roads dive underwater. Ships pass overhead. Locks manage elevation. Bridges coordinate traffic. Everything merges. This is not one solution. It is every solution combined. Roads surrender. Water dominates. Systems cooperate in silence. It feels like the future because it is. Not flashy, not dramatic, just inevitable. These places teach us something uncomfortable. Progress is not about convenience. It is about priority. And when engineers had to choose, they chose water. If this video changed how you see roads, bridges, and rivers, share it with someone who thinks infrastructure is boring. Like the video. Subscribe to Wonderscape, because the world you drive on every day is quietly surrendering, and most people never notice.